An array is a special type of object in which all the keys are numbers. These are two examples of arrays. The first one doesn't have any items, and the second holds 3 strings. Note the special syntax for declaring an array. All the values are surrounded with a pair of brackets, and the values are separated by commas. Only the values are specified and not the keys, because the keys are assigned automatically. The keys are based on the order in which the items appear in the array. The first item is numbered 0, so red has a key of 0, green has a key of 1, and blue has a key of 2. The key of an array item is known as an index, and an array item is known as an element. Individual elements of the array can be accessed by providing the name of the array followed by the index in brackets, which is similar to how we access values in regular objects. Note the absence of quotation marks around the 1. This code will actually work with quotation marks, but this is more verbose and unnecessary, so it's very uncommon to include the quotes. Also, dot notation will not work. This limitation is not specific to arrays. Regular objects also cannot use dot notation for keys that are numbers. Only bracket notation will work. Observe the similarities between the colors array and colors object. The array is slightly less verbose to declare, but it also has other special capabilities. There are predefined methods for arrays that are not available to generic objects. We will cover these shortly. If you attempt to access an element using a key that is higher than the last item's key, the result will be a value of undefined. This is the same that would happen when trying to access a property of an object that doesn't exist. Note that the index of blue is 2 because indices start with 0, so 3 is out of range. Although it's common for an array to hold all values of the same type, this is not a rule. This code is completely legal and doesn't generate any error messages or warnings. Any value that a variable can hold can also be held as a value in an array. This is an example of an array that holds objects. To get a value from an object in this array, we can use brackets to specify the array index, followed immediately by either bracket syntax or dot notation to access the property of the object. It is possible for the values in an array to also be arrays. This is known as a nested array. Accessing elements inside a nested array is similar to accessing properties in an array of objects, except that dot notation is not allowed. This code accesses the third element of the second subarray. What is happening here can be seen more clearly with a more verbose variation of this code. In this version, an extra variable is created to hold the entire subarray. In the more concise version, the first set of brackets gets the value of the second subarray, and the additional brackets after that gets the third item from it. This can also be rewritten with parentheses to show the order of what's happening. If we replace the expression in the parentheses with its value, we can see that the second pair of brackets is just getting a value out of an ordinary array that isn't nested. It is possible to nest more levels, and it is common to refer to the levels of nesting as dimensions. Accessing values in arrays that have more dimensions just requires using more pairs of brackets. This code accesses the letter C in the 3-dimension array. The first index with a value of 1 selects the array containing letters. That is a 2-dimensional array. The second index selects the first value of this array, which is a 1-dimensional array containing the letters A, B, C. The third index selects the third element of this array, and that has a value of the letter C. There is an alternative to using brackets, which is using the @ method. This example doesn't show any obvious benefit over using brackets, but the @ method can also be used with negative numbers to count from the end of the array, which is not possible with bracket notation. Note that the @ method can be used on multi-dimensional arrays by chaining multiple @. The first @ gets the last element of the array, which is an array with the values of A, B, C. The second @ gets the first element of that array, which is the letter A. If you want to access a contiguous subset of an array, use the slice method. The first argument passed to slice is the starting element's index, and the second argument passed is one higher than the index of the last element that you want to include. Here's another example not starting at the beginning. 30 is at index 3 and 60 is at index 6, which is 1 less than 7. It is also possible to use slice to copy an array by not passing it any arguments. Note that a simple assignment with the equal sign would not have produced a copy because arrays are objects. We discussed in a previous video that objects cannot be copied with the equal sign. This only creates an additional reference to the exact same object instead of making an independent duplicate. It is also possible to use the from method to copy an array. The from method also has other important uses which we will cover at a later time. A more common technique for duplicating an array is by using the spread operator, which is a series of 3 dots. Note that the spreading must be done in between brackets if you want to copy an array. The spreading actually separates the elements out from the array into a comma-separated list of independent items. Surrounding this spread with brackets causes those items to become the elements of a newly created array. It is also possible to use spreading to combine multiple arrays into a single new one. This code spreads all the elements of fruits and all the elements of vegetables inside a new array named foods. We can see what the spread operator really does when using math.max. This is a method that takes a comma-separated list of values and returns the highest value. If these numbers were elements of an array, we could not simply pass the whole array as an argument because math.max only takes a comma-separated list of values and it does not take arrays. Attempting to do this outputs NaN because an array of numbers is not a number. Having numbers and being a number are two different things. We can fix this with the spread operator. Spreading converts the array into a comma-separated list of values, which is what math.max requires. Note that no brackets are used here because doing that would convert the spread values back into an array. A related operator that can potentially be confusing is the rest operator, which also consists of 3 consecutive dots. What it does is the opposite of the spread operator. The rest operator creates an array from a comma-separated list. The output has brackets because the numbers parameter holds an array, but individual comma-separated numbers were passed as an argument in the function call. If you want to create new variables from values that are in an array, we can use destructuring as a shorthand. This is the verbose approach without destructuring. Destructuring shortens the code a bit. The syntax of array destructuring uses the same layout as an array, but it appears on the left side of the equal sign. Each item in this becomes a new ordinary variable, and the values they get depend on the order of the values in the array being destructured. The first fruit variable gets the value of apple because it is the first item in the destructuring, and apple is the first element in the array. In the same way, second fruit gets the value of banana, and third fruit gets the value of orange. Note that it is not required to apply the destructuring on all values in the array. In this version, only 2 of the elements are involved in destructuring, and the last item is not. Destructuring can be combined with the use of the rest operator. What happens here is every element participates in destructuring. The first 2 are assigned to individual new variables named first and second. All the other elements are combined into a new array named others. It is possible to use array destructuring to swap values. What happens here is an array is created containing the values of x and y, and that array gets destructured to assign new values to x and y. This is a bit clearer if we substitute in the initial values of x and y. This gives y the value of 4, which was originally the value of x, and it gives x the value of 5, which was the original value of y. Existing values in an array can be changed by using the equal sign for assignment. It is also possible to add new items to an array by using the equal sign, but the correct index should be used. If the index is too high, you will get empty items in the array. This in itself is not really an error, but it wastes memory, and it can lead to problems if your code is written with the expectation that every element has a value. Arrays have a length property which provides a count of how many items are in the array. Because indices start at 0, the length of the array is always equal to the index that the next new item should get. So it's possible to use that to add new items without creating empty elements. This technique works, but there is a simpler way to do this using the push method. Notice that black has been added to the array and it is at the end. The push method always adds the new item to the end of the array. This new item also automatically gets an index that is 1 higher than the previous last item's index. Blue has an index of 2, so black automatically gets an index of 3. If you want to insert the new item at the beginning of the array, you can use the unshift array method. There is still much more to the topic of arrays. We will continue with this in the next video.